the first thing I'm thinking as we look at Planning 15 is I want to go to the implementation guide because there's a lot to this concept development. So you have like, it's problem one, it's problem two, and they're very long. And so the first thing I'm thinking is, let me go to the implementation guide and see what the focus problem is in the concept development. Because if you try to go through all of this, you're probably running short on time. So the tool that I go to is, yep. So here's lesson 15, and here let's say focus concept development problem number 1. So while there are multiple problems in the work, you really want to focus your strategies on concept development 1. Then I'm going to say, okay, when I get to the problem set, what problem do I have to have done in order to know whether or not students are on their way to mastering content? And you'll see here it says problem 3. It doesn't mean that problems don't matter, but it means that problem 3 is the problem that's going to tell you whether students are really even ready to go to execute it, right? So how you manage that in your class might be everyone do the first problem and then go straight to problem 3 and then go back to 2, right? Because that means that everyone will then get a chance to do number 3, depending on the speed they work. And especially these manipulatives, there's going to be different people working at different paces because these manipulatives are going to work slower. So, so let's now we're going to focus on problem 1 in concept development. Now let's look at the problem. All right, I'll give you a chance to read it. Is it much different than what you did yesterday?
No.
All right, what's different today than yesterday?
We got the area model.
The area model, and did you have remainders yesterday?
Sorry, 2 remainders, yes.
Okay, so the only thing different would be the area model, right? All right. How do you go about first connecting what you did yesterday to the work today? And so the target you're going to stay today is what?
I can divide using area models and arrays.
Okay, and how did that connect to the work yesterday?
Right, so I'd say, well, yesterday we used arrays to represent division problems. Today we're going to use arrays, but we're also going to use area models, and then go over what an array is and what an area model is.
Perfect, because we want to make sure the target connects to work they've done before, so that they don't think the work is always done in isolation. Right? Everything is built on something we did before. So now we're jumping into the problem. The first one is 10 divided by 2. How do you want to start this problem?
Yeah, well, what I was thinking more generally for division, I want an anchor chart that explains the numbers in the problems, with the math terminology, but also, the number that you're dividing, is your total that you start with, and then when you divide it by 2, it's and how many groups you're going to have, and the answer is how many are in each group. Sorry, that was kind of...
No, that makes sense. Yeah, so you start with a total, you break it into...
And then I want to have a multiplication sentence under it, being if you have 3 times 4, you have 3 groups, there are 4 in each group, and then the answer is the total, so they can kind of see the connection between the 2.
And you'll notice that today's work
today
does
is
exactly
really related to that.
Right?
Yeah, exactly. Yeah. So I definitely want to have that up.
So you have 10 divided by 2. How do you start the lesson for students?
Yeah, so I'd start by having them draw an array.
Make sure they write the equation somewhere along the way.
I always have it on the board. This is what you write down first. Okay. Yeah, so I guess step 1 I'd be write the equation.
So they're gonna build an array.
Yep, so step 2 would be build an array.
And what misconception might you anticipate in the array?
10 divided by 2, some of them might do groups of 2 when they're splitting it up instead of groups of 5.
So be ready for that, right? You want to anticipate that as a misconception, that even in building the array, students might flip it and do 2 groups of 5 instead of 5 groups of 2.
Right.
I'm sorry, 5 groups of 2 instead of 2 groups of 5. I just did it.
Yeah,
they might do 5 groups of 2 instead of 2 groups of 5, right? And 10 divided by 2, like you just said, is 2 groups of 5, not 5 groups of 2. All right, and then what are we going to do? How do we pull the area model into this now?
I'm thinking I would almost have them, well, not almost have, I would have them draw out the area model representing with an area of 10,
Mm-hmm.
and then ask what similarities they notice between the array and the 10, and what they
Okay.
probably say is that it's 2 equal rows. So
Okay.
yes, these both represent 10. We
Yep.
have 2 rows of 5, and 5 and 5 makes 10. So
I think what's important to draw out in this is that the numbers in my equation are going to be used to build my area model, right? And like you said, 10 is the whole. So when I make my rectangle representing my area model, the whole goes on the inside because that's the whole.
right.
The 2 will represent either the length or the width. It doesn't matter because I can multiply any way I want. If you align the picture to the image, then the 2 would be on the short side because 2 is smaller than whatever other number you're going to need.
Right.
But that doesn't really matter when they put the 2 here or the 2 there,
Right.
right? Then you're asking them what? So now I have my 2 on the side, my 10 in the middle. What are you asking them to connect the area model to the array? So you have this right now.
Yeah.
What are you asking them to draw out that information right there?
Oh, so you're asking me to draw like how many are in. See, it's not each group though for the area model.
So a 10 here and a 2 here, right?
Mm-hmm.
I'm still trying to figure out how many are in each group.
Right.
So what I'm asking for, if I think about this as area, which is what the area model is, what am I asking for to draw out that number right there, the length?
Like, so I'm not quite
So
sure
if you
what
think-
you're asking.
So the area model essentially represents area, right?
Right.
So you draw a rectangle to represent your area.
Yeah.
You have the 10 as my total in the middle. I have a 2 as my, let's say, width.
Mm-hmm.
If I know that area equals what? The formula for area.
Length times width, yeah.
Length times width. So I know my A, I know my W.
Yeah.
What am I asking them to draw out that number there?
The length.
What is my length, right?
Yeah.
And that's how they come to that number there.
Mm-hmm.
Because my area is 10 and my width is 2, then my length must be 5 because now I have 10 divided by 2 is 5. Or like you were saying, 2 times 5 will give me the 10.
Right.
Right? So that one's pretty simple and straightforward because there's no remainder. We move down here and it gets a little more complicated, but it's really the same work, right?
Yeah.
So your first step is going to be what?
First step would be.
For your work here.
Do I have them draw an array for the second one too?
Mm-hmm.
Yep. So step 1 would be drawn.
Well, let's go back to
Step
this
1
one.
is. Wait, for which one?
This first one here, because you have the angle comes from the first one.
Right. Okay. Yeah. So step 1, I had the right equation. Step 2, I had builds an array to represent the equation. Step 3, I said draw an area model, but then I have like kind of substeps. So like the whole goes in the middle,
Yep.
and the number that you're dividing by goes as one of the side lengths.
Yeah, it could be length or width. It doesn't really
length or
matter which
width,
one it
yeah.
is. Yep.
Yep. Side length, and then you want to determine
So yeah, step 3 is
the unknown.
right. Step 3 is determine the unknown. Yep.
Yep.
Now, the interesting is this. Some kids will say, oh, 10 divided by 2 is 5. Some kids will say 2 times something equals 10. So it'd be interesting to have them flesh out how they figured out the 5.
Right.
And I wouldn't necessarily name it up here. I would wait for them and do it down here,
Right.
right? Because I don't want to give it away here.
Mm-hmm.
But I'm curious to see which way your kids are thinking. I believe, just in my experience, a natural tendency is to do the unknown multiplication, then division.
Yep.
Right.
That's what I do even. Like
Yeah.
I'm doing something, but yeah.
But in here, it's a little bit different. What's different about this one than the last one?
We have a remainder.
We have a remainder. So now you're doing the same thing, right? Step 1, what is your equation? 11 divided by 2. Great. Step 2, you're going to build your area model, right? Now, this is where this student have to go through the thinking, right? 11 is not divisible by 2, right? And if you draw the array first on this one, they'll see that. Because you'll have 6 on the top and 5 on the bottom, right? Feel free to do that. You don't have to, but you can. Now you're saying to yourself, what?
Like how would I explain this or how?
Yeah, like, so you put your two, you draw your area model again. You know you have 2 on the width, right? How do you, what's the question sequence to get from this to that?
Yeah, well, right, so if I don't have this, right, so am I building on, in this example, am I building on that one that they already have, so they already have theirs, and
Yep.
now we're like, okay, well, what if it was 11 divided by 2?
Yep.
Okay, so what I have them do is think about, okay, well, for now we're doing 11 divided by 2, and I know that my area is 10, how do I make an area of 11 instead? And they would probably say add 1.
Yeah, but I think, so you're doing 10 divided by 2 plus 1 is the way you're kind of thinking about it.
No, I'm thinking 10 divided by 2, but if they just had the picture, right, that looks like this, right, my first step 1 would be or after building an array, like how do I, so I'd have them match it to the array probably. I'm trying to keep it consistent with the
So
steps.
what I'm thinking is, if you're trying to find the area, and even on the first one you're saying is 11 a factor of 2? I don't know. Let's count by 2s. 2, 4, 6, 8, 10, 12. If I can get to 10 and 12 again, get to 11, is 11 a factor of 2? No. What number is close to 11 that is a factor of 2? Can I use 6? No, 6 is too big. Can I use 4? No, 4 is too small. And I go through that question sequence for numeric fluent, for numeric awareness.
Right.
So what can I use? I can use 5. Great. So if I use 5, then I get my area of 10. But what's my real area here? 11. So what do I have to add on to 10?
1.
Add 1. So I would do it that way, right? Figure out how close I can get, and then add on the remainder, because that's all the remainder really is, right? So you might say, okay, guys, now they want an area of 11. And I would go through that. Is 2 a factor of 11? Let's count by 2s. 2, 4, 6, 8, 10, 12. Uh-oh. It's not a factor because it doesn't go in evenly. So I'm going to use 6. Can I use 6? No, it's too big. All right, I'm going to use 2, 4. That's too small. What number can I use that's close to 11? You can use 10. Great. Let's use 10 and solve for the unknown. What's the unknown? 5. That gives me an area of 10. And then 11. What do I have to add on to 10? 1. That 1 is my remainder.
Right, okay.
You understand what I'm saying?
Oh, I see. Okay. Yep.
And they're doing the same thing here. So let's look at this one.
Oh, because this sets up directly for long division, because what goes into it. That's okay. I see it now. Yep.
There you go.
The remainder, that's they're gonna bring down. Okay. Sorry, not bring. You know what I'm talking
Yes,
about.
that's what's left after you finish. You can't divide. That's what's left. So let's look at this one, and you might, let's say, do this one. This one's actually pretty quick after that. That's a build on to that, right? And then I would jump to this one.
Right.
And so walk me through this one.
Okay, so they do 16 divided by 3. So I would have them do the array first, because I think that is
Okay,
helpful.
I think that's right.
So
So how many groups do they have in the array?
3.
Gotcha.
Yeah,
Okay.
so they have 3 groups. Then they're going to draw their area model.
Yep.
We're going to talk about, so what goes in the middle, what's our whole. 16 goes in the middle. If we're dividing by, so do we know any of our side lengths? Yes. Why? It's 3, because that's what we're dividing it by. So our side should be 3, because we have 3 rows, or 3 columns, whatever they say, but 3 rows. So okay, how do we determine, right, what our other side length is? Like, how do we know how many are going to be in each row? Like, okay, well, I know that. So they could do either the multiplication with the missing number,
Well,
or they could do.
so we're at 16. The question is 3 a factor of 16?
All right, it's 3 a factor of 16.
Because that's the only way you get to a remainder is if it doesn't go in evenly.
Right.
So let's go back to drawing the array, right? So go back to that, and I know 3 is my side, what you said.
Yep.
Right? Do I know my other length?
The answer is no.
No. What's my whole?
16.
Is 3 a factor of 16? Let's count by threes.
Right, and the answer is no.
No.
Right.
Can I use 8? 8 is 16. I'm just going to use 8. Does that work?
No.
No, it's too big. How about we use 4 and I use 12? Does that work?
No.
No. What number do you think I should put in the middle that's a factor of 3?
15.
15. If 15 is my whole now, what is my unknown side?
5.
Great. But now I only have 15. What is really my whole?
16.
So what's my remainder then?
Remainder is 1.
So now let's walk. I want you to walk through that now.
Okay, so
Because you have to, in this, we have to figure out whether my part is a factor, because my whole has to be a number that's a factor of my part in order to get to the remainder.
yep. Okay, so do I want to do that? I want to do that. I'm trying to figure out whether I should do this during the array or during the. So no, they should just draw the array. And
The
then
array
do it.
just shows it,
Right.
because you see that I can't fit even numbers in each group. That tells me there's a remainder.
Right.
I don't know what it is yet, but the fact that I can't create an array has to be equal.
Mhm.
The fact that I cannot create an equal array tells me there's a remainder,
Right.
right? Because the remainder is what's left over when I can't share evenly.
Mhm.
And it's important to understand that language. Like a remainder is what's left over when I can't share evenly. That's what remainder is. It's what's left over.
Right.
So now the idea in this lesson is to get to a place where you can share evenly, and then what can't be shared evenly becomes my remainder. Which, like you said, sets up long division,
Yeah.
right? Or even error model, we do like the before even long division, all the division is set up with understanding when I can't share evenly, the remainder gets regrouped, or the remainder is called the remainder,
Right.
right? So let's walk through this one again. So create the array, and what's the conversation when they make the array? Like what's the noticing when they make the array?
The noticing is that there's a remainder that they can't split it.
I can't share equally.
Mhm.
I can't share equally.
Sure, cool. Mhm.
Your turn. I can't share.
Okay. Okay. So
You get to teach, I'll be the student.
yeah,
All right. Go.
I'm trying to rethink because how I was going to explain it is definitely not how I'm going to explain it.
All right.
So I'm just trying to rethink.
You're going to make an array, right?
Yeah,
So make an array of what?
of 16.
In how many groups?
3.
Gotcha. So I got 3 groups. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Huh. Miss Aruda, I can't make equal groups. I have 6 in one and 5 in the others.
Right. So I'm trying to think of how do I move on and connect to the area model. That's what I'm trying to think of.
So great. Let's draw the error model.
Okay.
What do I know in this problem?
Right. So we know. So we're gonna draw our area model. What do we know? We know that our whole is 16. So where does the 16 go? It goes in the middle. What else do we know?
I know part of my array is 3. Part of my error model is 3.
3, right? So we have 3 rows. So we're gonna write our side length as 3. Now we know, right? Is 16 a factor?
3 a factor of 16.
Sorry, 3 a factor of 16.
I don't know.
No, so okay, let's count together. Right?
3, 6, 9, 12, 15, 18.
So is 3 a factor of 16? Sorry, 16 a factor of 3?
3 a factor of 16.
3 a factor, yeah.
No, because it doesn't go in evenly.
Okay, so what's close to 16, right? What's the closest we can get to 16 that is a factor of 3?
15.
15. So we're gonna make our whole 15. Right, what's left over to get to 16?
Well, first, before that, if my whole is 15, what is my unknown
What's my
side?
unknown side? It's 5.
Yep. Well, they have to solve for that.
Yeah.
Right.
Yeah.
And then you say, what?
Right, and then, okay, so now, right, we have our whole is 15. What's our whole supposed to be?
16.
16. So what is our remainder? What's left over to get from 15 to 16?
We need to add 1.
Add 1. So we're going to add 1 to our area model.
Just like that. And that's 1.
1.
Right? So really, so what you want to do is you want to start by build the array.
Mm-hmm.
2, discuss the array and what the array shows you. right? You want to flush out that I can't make equal groups. So I have to figure out something about this problem, right?
Right.
Okay, now let's build an area model. We know one side is whatever that number is. I know my whole is whatever the number is. In division, I always want to share equally. Can I share 3 equally into 16? I don't know, let's count by that number. No, it doesn't fit equal. Great. What whole number does 3 fit equally into that's close to 16? 15. Great. So let's change our whole from 16 to 15 and figure out the unknown side. Now I figure out a whole if it's 15. But what's really my whole? 16. So I'm going to add 1 and call that the remainder. Right? And but it's you want to flush out, here's what I have. Here's what I'm starting with. That doesn't work. Let's make something that works and then figure out what's left. Right? So let's do this one, and then I think you gotta get ready to go. Let's flush out this last one here, and treat me like I'm the student.
Okay, so step 1, we got our equations. What is our equation? Equation is 23 divided by 4. I'll have that on the board.
Okay.
Step 2, we're gonna build our array. So we're going to take 23 and we're gonna make 4 groups.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23.
Can we share 23 into 4 groups equally?
No, I can't.
No, so let's build our array. Not array, sorry. Let's build our area model. So we're gonna build our area model. What is our whole?
Whole is 23.
Okay, great. Kent does.
Put 23 in the middle. Start with that. So
Okay, we're gonna put 23 in the middle. Okay. What is our side length?
4.
4. Can we share 20 equally between 23 into 4 groups?
No.
No. Okay. What number can we share equally that's close to 23 in 4 groups?
I don't know.
Could we share?
Let's count by 4s.
Oh, let's count by 4s. Okay, let's do 4, 8,
12, 16, 20, 24.
Okay, so what number is close to 23 that we can share equally in 4 groups?
24.
24. We can, but do we have 20 more or less than 24?
We only have 23.
We only have 23, so can we use 24?
No, we can't.
No, so what number can we use?
4, 8, 12, 16, 20.
20, great. So let's make our area model with 20. So if our area is 20 and our side length is 4, what's our other side gonna be?
5.
5, okay, are we done?
No.
No, how much is left over if we have our area model of 20 and our whole is 23?
3.
3, so we're gonna add our 3.
And we're gonna.
Oh, we're gonna call that, right, so what is 3 called? 3 is our remainder.
3 is called the remainder. Why?
Right, what is a remainder? Remainder is what's left over.
There you go.
It remains.
There you go.